recording is set up.
All right, well, it's 4:05, and for reference, I think we'll go ahead and get started with this. So hello, everyone. Welcome to the Engineers for a Cause SolidWorks workshop series. This is the second workshop in the series, which will be dealing with SolidWorks project management. And yeah, I'll go ahead and dive right in. This workshop will be done in two parts. One will be covering a feature of SolidWorks known as document properties, and the other section will be covering more of the project management side, so project lifecycle management, engineering change orders, and everything in between. So without further ado, I'll go ahead and jump right in.
Yeah. So for the first part, we're going to be talking about using custom properties in SolidWorks and kind of what features that has for you and how that can actually help make your documentation and your tracking process a little bit easier in the long run. We'll go to the next slide.
All right. I'll go ahead.
Yeah. So for custom properties in SolidWorks, there's this feature that's circled in red when you have SolidWorks pulled up for a part. And that's going to be the symbol for file properties. And that will pull up this window that's kind of small, but you can sort of see it here. And essentially what this lets you do is this will let you assign any custom properties that you would like to have done on your part that you're working with. So I think the next slide has a slightly bigger picture of it. Yeah, there we go. So basically it's filling out any information that you want to be storing along with this part. So this sample that we have here has some of the set parameter names, I guess you could call them, within SolidWorks. So you have things like designed by, the design date, what revision it is, what material it is, things like that. And so we'll revisit it a bit later, like it says here, but those you can label them like designed by, and I think we have Jeremy's name in there, so you can say who made this part and what day was it made, what revision are we on, what kind of materials is this supposed to be. And so what this does is that it saves with the part that you're working on, and this information will then go with it, and it'll be able to let someone know essentially what you saved. So who made it, when did you make it, and if they had questions on that, they could always go back and look and say, who made this? I don't understand what's going on or why a change was made. And then it's an easy, okay, Jeremy made this, I'm going to go ask what or why the changes were made.
So I'll go ahead and actually switch my screen over to SolidWorks right now. Oops, let me back that up once. Share screen one. Is that coming through okay?
Yep.
Okay, so I'm on SolidWorks right now. I have a random part, right? This is just basically a square that's been extruded, and really the part doesn't matter. So what I'm going to do is I'm going to actually go to file properties right now, and you can kind of see what I filled out in here. So you can see all these property names. Essentially, I've name tagged. I said, okay, who made the part, right? So I can say designed by, who designed it, and that all that, as Lauren said, all that information will carry over. You know, when was it designed, what revision it is, and we'll get into revisions on the next slide, actually. What material it's supposed to be made out of here, I'm specifying 5052 H32 aluminum stock. Finish, none. Sometimes when you machine their various parts, they'll be anodized or dipped in a chemical film to prevent rusting, or a few other forms of essentially finishing the part or putting a coating on it for different purposes. In this case, I'm specifying there's no coating, and the description here is just saying, it's an aluminum block. Pretty straightforward, right? And we will revisit all of these names here, these property names, in a little bit. So I'm going to go ahead and switch the screen share over back to custom properties, and on to the next slide.
Yeah. So we've been talking a bit about revisions. So revisions are essentially a way of keeping track of what you're changing and what version of your design you're on. So if you started out with your first drawing and your first assembly, that's going to be revision A. And then, like this example says, if you 3D printed that and the screw holes ended up being too small for what size screw you need to be using, you would then go in and alter your original part to increase that size of those holes. But then you wouldn't necessarily want to just overwrite everything that you originally worked on. You would want to resave it as revision B. So you know essentially where you came from and where you're going within your product design. So you want to be able to, and then also labeling the revisions like in the custom properties that then helps you and your teammates, if you are working on a team, know what's the most current uh, file that you're working with. You don't want to have one person on your team be using revision C, but someone else missed the memo and didn't realize that there was a new revision, so they go and they print revision B. So you want to be making sure that you are keeping track of this and that your team has somewhere to be tracking where the product is in the revision process. But we'll go more in depth with that a little bit later as well.
Um, and so yeah, basically Lauren just covered essentially, why do people do this, right? And using the old fixed parts I mentioned can be catastrophic. I actually have an instance there for work. I was working on essentially I was working on an assembly of I don't know how many thousand parts. Um, and one of the other engineers who was working on it is asking, hey, why is this piece here, right? This is kind of redundant because the assembly was an updated version, like a new product, but it was kind of based off an old product. The old product didn't have the piece there. And they were like, why is this here? Can we just get rid of it? Is this, action necessary? And one of the under engineers, in all caps, writes an email back and says, no, we can't, right? Because apparently that block being there actually prevented a moving part from flying off the rails and breaking the whole machine. And that's one of the things that was basically created in a revision, but either the first engineer didn't see that this was part of the revision or that particular revision wasn't documented. And essentially the idea behind the revision is saying, all right, we screwed up, or something needs a fix, or that doesn't work. And how do we make sure that we don't keep doing this? So we make the change, how do we specify, okay, nobody use the old part because the old part sucks. And second of all, how do you make sure that someone down the line doesn't go, oops, we did it again? So I'll go ahead and bump over the slide to the next slide.
Yeah. Yeah, so actually implementing the revisions. Um, like we were saying, a lot of companies will use this for their products as well. But they usually have the money and the technology to be able to kind of use this fancier Vault software that keeps track of all of your SolidWorks files and what revisions you're doing and any of the documentation for that. We're assuming everyone here is undergrad projects, and so that's not really something that's feasible or realistic for your uses. And so something that you can do that's very easy is just using things like Google Drive and Google Sheets to basically create a vault of your own. And so setting up a very simple Google Sheet that essentially just lists each part that you're working on and has a check in and check out kind of column. So who was the last person to work on it? On what day were they working on it? What revision are they on? And what did they change? So just keeping track of very simple parts like that will save you a whole lot of trouble down the line from mixing up parts or accidentally redoing what you already did and ran into problems. So it's basically just taking all the work that you're doing and consolidating it into one centralized place where everyone has access to it and everyone can keep track of what's going on and who's doing what.
Yeah. How many of you have, I don't know, like, I don't know how many of you are in the MAE department, but how many of you have taken MAE 3 at one point or another? Feel free to ping in the chat, like, list
Not
your,
one.
oh, Caitlin has, and okay, Noah, you have as well. Um, so I'm not sure if any of you remember, but I know something that happened to me when I was doing those projects. I was kind of the main, I guess, person handling the CAD files for the project. But everybody would work on different components based on who had time for what and how they could do it. Um, and what ended up happening is we had a Google Drive, right, where we could upload all of the CAD files. We're using Inventor. But what ended up happening is people would download a CAD file, work on it, not upload it again. We had 3 or 4 different copies floating around different people's devices. And we had no method of tracking revisions. We kind of just like upload, download, upload, kind of willy-nilly. And what ended up happening is we ended up having like going to have some parts laser cut, and then we realized, wait, this isn't the right part. We fixed that last time, right? And material, we end up having to essentially go through purge the entire, I guess, quote unquote, simple of a class and project it is. Like it's just a 6-week robot with acrylic parts. Now imagine somebody dealing with an assembly for, and I'll use this example later, but maybe a machine that can sort trash out, like sort parts that not only are you manufacturing, but you actually have to buy from, suppliers. You might be dealing with electrical parts. Imagine trying to organize essentially all these like raw part files, all these like essentially fabricated designs, and keep them on lock. It becomes very, very difficult without any sort of revision control. So, well, getting back to SolidWorks, it's kind of blurry here, but I'll go ahead and show you in SolidWorks. So I'll go ahead and switch my screen over to screen 1. Can you all see that properly?
Yep, you're good.
Okay, so we're back to the block, right? Let me go ahead and make a drawing from this part. Well, just a standard drawing template. And wait for that to load. Okay, SolidWorks. I'm gonna go ahead and set it to, my ANSI A template is a little bugged right now, so I'm gonna go ahead and set it to an ANSI B landscape, right? So this is a pretty simple drawing. As you go on through engineering, drawings are used very, very heavily to deal with machine parts for 2 reasons. One, because it's a very, very easy way to essentially distribute an unchangeable referenced version of a part that you want machined, and you can go ahead and give that to, for example, a machine shop, or you can go ahead and give that to your producer or your supplier and have them make those parts for you without actually having to give them access to your SolidWorks files or having to essentially like upload and download those, transfer around those SolidWorks files and essentially lose track of them. So what I'm going to do here is, you can see the standard drawing template. What I'm going to do here is actually bring up the file properties. So calling back to section 1, I'm going to designate, I'm going to start name tagging this file. So watch what happens when I do this. So I'm going to specify drawn by, and this is the reason I use drawn by, and I'll show you in a little bit, is, actually I'll show you right now. Let's go ahead and go, right now you're in edit sheet mode. So essentially you can mess with what's on the sheet. I can put the part on there. And you can see some stuff pop up, and I'll get to that in a little bit. So I can put the block on there, let's just put the part there. Now, if I go to edit sheet format, what this allows you to do is actually start messing with the format of the sheet. The outlines, you can modify the tables. And let's take a look at this, right? So it looks pretty normal from here, but why did this aluminum block, where did this come from, right? If you recall, that was actually the description that I set for the parts that I'm having put in here. So let me go ahead and mouse over some of these little word blocks. So in this standard ANSI template, there are several built-in text fields. This up here, this section over here is usually for putting your company or your project logo. This over here, if you look at the text, you can kind of see it like, it's kind of small, but you can see how it says $PRP sheet :description. And so what $PRP sheet means is it's referencing the part that is on the sheet. So if you remember this part, this aluminum block, it's referencing the property. It's referencing the custom file property of this part. So depending on what you named it for your description, it will always automatically show up on here. And maybe, you know, for different companies, they'll have different templates. So usually if a company has a SolidWorks like design template, they'll have their own like name tags for different things. But essentially the principle remains the same. It will, if you use your file properties properly, you can get certain aspects and certain descriptions from your part to automatically show up on your drawing. And it saves a lot of time. And it also makes it clear, you know, what's going on here. And let's go mouse over a couple different things. So this one is $PRP SW file name. So what that's referencing is it's also referencing the file property, the name of the part that you put on it. I named it BLK1, block 1, right? And so it's showing that up. I'm going to go ahead and mouse over a couple other things here. And you can see here that says, if I click right there, you can see like it was invisible at first, but then a box popped up. Let's mouse over that box and see what it is. So it pops up and says $PRP drawn by. So it's referencing, again, the custom file property inside that's stored with the file. So I'm going to go ahead and actually bring that up right now and watch what happens. So I've seen, you know, that was PRP drawn by, PRP drawn date. There's some other things like PRP check by, PRP engineering approval. So if you fill out, essentially you create a custom property or a file property with that as a name, engineering approval, something will show up in that field. And also there's PRP revision. If you recall, we were just talking about revision controls. And when you put down a revision, it'll automatically show up on your sheet. So I'm going to go ahead and bring this up. I'm going to input the data. So drawn by me, drawn date, and today's date is, and there's different kinds of types of, you can have it automatically input a date as well. Actually, I'm not getting that to work right now. So, I mean, I can just enter it in this text. It doesn't really matter in this case. And so I want to know check by. Okay, who on, you know, for example, for check by, let's say you're working on a project team and, you know, you're working on a part and you have like your team lead, you know, or your team sub lead. Let's take, you know, for example, Engineers for a Sustainable World, they have SolidCar, you know, there are 3 different engineering sub leads. And let's say you're making part of the chassis, then you'd be reporting to, per se, the mechanical sub lead. And so, you know, your checker might be the mechanical sub lead who asks, or whoever asked you to do this part would be your checker. You know, that once you do it, they check it over. And then so whoever's reading this part, if they have questions, they can't reach out to you. Maybe you can ask your checker about it. You know, what is this? What does it do? Why? Kind of deal. So for here, I'm going to set Lauren as my checker. And check date is today, 11/6/2020. So watch what happens. As soon as I go ahead and prove that, actually, let me add a couple more things. Revision, always important. A, is first revision of this part. And I'm going to go ahead and it out, and look what happens. That's just popped up in fields. You know, it shows who drew it, when, who checked it, when, and I'll like to bring in, obviously, the revisions also showing up in here. So if I was to say, you know, maybe I made a change somewhere down the line to the file, I could say revision B, to change the revision manually to B, and it'll show up on the document. So when I actually go ahead and save this document as a PDF, maybe I want to send it to my professor to get a look at, or maybe I want to send it to, you know, company, like a machine shop or a company to get it manufactured, because a lot of times if you're dealing with prototype parts, it's a lot easier to, you know, have a machine shop or somebody do it for you instead of trying to have the engineers do it themselves. In terms of money and time, it's a lot more efficient that way. So send it out. It'll show all of this. And one more thing is, if I'd like to bring your attention to, is again, edit sheet format. take a look at this. It even shows the material and the finish I listed in the sheet properties. If you remember, this $PRP sheet material, it's referencing, what did I put for the material feed in my original parts? Cool. There we go. So if, yeah, right here I have listed material 5052 H32 aluminum, finish none, and as I close that, well, that's not a problem right now. I'll deal with it later. As I save that, you can see it shows up here, and proper sheet material, and it'll show up on your sheet. What is this thing made out of? And I guess moving on to the next part is also, revisions again. You can add something that's what's called a revision table, and I'm going to go ahead and click on that. You go to tables. There's all kinds of different tables that you can use here. You can add a bill of materials. You can add that's not useful for something like this where there's only one part, but for something like an assembly where you have maybe a block mounted to another block mounted to a motor on it, and you can add a bill of materials to specify, okay, what part is what and where it is. Oops, that is a mistake. So let's go ahead and add a revision table. So you can check your template. Oftentimes companies will have their own templates. I'm going to go ahead and add just the standard revision block that SolidWorks has, because I don't make my own templates. I'm not quite up there yet, if that makes sense. You can pick what symbol you want. So, and I'll show you this in a little bit. Let's go with the hexagon for now. There's some settings for how big you want the borders on. Layers are not really a big issue right now. Let's go ahead and add our revision table, right? Look what happens. It shows up in the corner. You can move it around, obviously, but most companies will stick it in the corner like this. So I'm going to go ahead and add a revision. When I press B, it'll automatically add a table. You see this little hexagon that pops up? This is essentially a revision marker. So I'm going to ignore that for now. So revision A, initial release, right?
Remember, we have a question about how you ended up getting that table to show up. You could go over that again a little bit slower.
Right. Okay, so I'm going to delete the table because you can only have one revision table at once. Let me go. Okay, so tables. So you see all this, drawing. These are all the views you can put for, your parts. View layout, which is, again, more views. Annotation, which is the actual important parts. You can put dimensions. You can put a note in it that says, hello. Right? And different, they'll have different leaders on them. There's other symbols that are used to essentially specify, how do we make this part? And there's blocks, which are essentially, custom compilations. So maybe if you had a sequence of notes, like for ANSI standard or ASME standard, you could store that as a block. Other things like that. And so, but for the revision table, let's go to tables right here. Tables. So we have general table, whole table, bill of materials, revision table. Let's go ahead and grab revision table. Let me move that up. There we go. Go ahead so it's a standard revision block. And as I mentioned previously, maybe your company has a special revision block. I know mine does. Or maybe you make your own fancy revision block because you want to add extra notes to it. I'm going to go press OK. Choose a symbol for revisions, and press all right, and there we go. It pops up in the corner. I'm going to add a revision A. What was the first revision we made? And I'll go ahead and put initial design, and this description of its release date 11/6/22 and approved. You can specify if you're who it's approved by. So let's say you're in a project team and your project lead or your sub lead or whoever, or maybe you're, the person who's in charge of your small squad of people who are working on the very specific piece of the drivetrain of this machine you're working on, approved it, and you can specify who approved it. Bob or something, right? Bob approved it. Cool, great. We'd love to see it. Anyway, and let's say maybe somewhere down the line you make a fix. I'm not going to go ahead and I'll go ahead and actually make the fix now. Let's make it longer. So, 99.3, let's make it 110. So, obviously the part has changed a little bit. And now when you go back to your drawing, it doesn't look like too much change, right? But you know that you changed something about it. And, maybe I changed it because I wanted a bigger block, right? And, that's a reason for it. Normally you'll actually have a proper engineering reason for making a change to it. And so I can say, actually, let me delete the original part and add a different drawing view, more proper drawing view for manufacturing. Top side view. And to make this simple, I'm just going to go ahead and throw a few dimensions on it. Y'all remember how to do dimensions and all that. Oh, this is in inches apparently. That's fine, whatever. Usually, well, so yeah, there we go. Oh, it's in ISO drafting standard right now. I'm going to switch to ANSI drafting standard. Don't worry about that. That's mostly just dealing with, what kind of drafting you use. Most people use like ANSI drafting standards, and it changes how things are listed out. All right, so here's my initial design. Let's go back to the parts and go back to this. Smart dimension. 50, right? And so if you go back to your part here, so am I losing anyone? Are you guys still okay? Everything going okay? All right, there we go. It's back to millimeters. Let's say now, I need the part to be smaller for whatever reason, or I need the part to be even bigger. Go back to block 1, make an edit to the sketch. Say, I want that to be 120 millimeters long, right? Not a big deal. So now, for here, I can say, oh, I revised it, revision B, we made it longer. So go ahead and click revision B, and that way, if somebody gets a hold of this part file right here, they'll know, okay, somebody changed it somewhere down the line from the original part A, and then they can reference, all right, why was this changed? And they can ask some questions about it and take a look at that. Let's go ahead and save the changes to it and close it. And now you can see, well, sir. Apparently that didn't change. I'll be right back. I'm gonna go ahead and fix that. I don't think it saved the length extension. 120, yeah. Okay, so what's going on right now is it's probably taking a while to update. Oh, there we go. Wait, hang on. Okay, for some reason this part's not updating, which is really odd. Normally, if you have a part being referenced, it'll update automatically. But since it's not, I'm going to have to probably. Let me go ahead and actually, yeah. I don't know what's going on, guys. I don't know why it's not updating. It normally will, if you change a dimension like that, it'll automatically update. Wants me to reload the sheet now. And it's still not updating. Apparently SolidWorks wants to lag now. Great. Of course, the one time where things can go wrong, they do. I'm just going to unsave the part. Then we'll stop lagging. And let's go ahead and reopen the drawing for this. And somewhere in there, we ended up losing the front part of it. So I'm going to re-add a projected view, insert drawing view, projected, right there. All right, sorry about that. It's working again. Now the dimensions will show up properly. And now you can see, I changed that from 110 to 120. So I'm going to go ahead and delete this column. Oops. Delete row. I'm going to delete the row so I can show you what I was initially intending to do. You can specify a new revision, essentially, a new revision B. And see this little circle here? This is your revision symbol. And it'll show up, B was changed. And so for this revision table, I can usually specify, what kind of symbol I want. So like, maybe I want a hexagon instead. And so go ahead and delete that. Corresponding revision table row, and now it'll show up as hexagon. So I have a little hexagon symbol, and I can mark B, and I can say changed for 20. And that's the point of the revision. Essentially, your revision table allows you to, at a glance, look at this document, say, all right, something was changed from revision A. You can say, okay, what was changed? Changed upper dimension from 110 to 120. You can see, oh, right here, there's the change, and proved by Bob again. Right. And you can also specify exactly what zone it's in. So we can say, in B3, usually this is a big deal in like bigger drawings where there's a couple hundred parts running around a single screen, and you need to know exactly where to look to find the little symbol. So say B3. So in zone B3, there was a change. You can see the location where it's marked, what was changed, changed upper dimension from 110 to 120. And that, in a nutshell, is how you essentially do revision tables. Does anyone have a question or a couple questions or anything right now? All right, doesn't look like anyone has questions at the moment, so I will proceed onwards.
And if you guys have questions at any time, just put them in the chat and I'll make sure we stop and get those answered.
All right, well, doesn't really look like we have any questions at the moment, so I'll go ahead and switch my screen share back over to screen 2. And let's take a look. Okay, part 2, product lifecycle management. This deals with POs and part organizational tactics. So, let's recall a moment. Let's go back to when we were talking about, the absolute mess that was MAE3. And let's talk about, don't know how many of you remember, like, okay, which parts are we still working on? What parts are done? Then you'd be sitting there, with a couple hundred inventor parts because, well, we didn't use SolidWorks for MAE3. Sitting there with a couple hundred inventor parts, really messy AutoCAD on something that's supposed to approximate a sheet of acrylic. And, you're standing in line for the laser cutter and you'd be like, wait, am I cutting the right part again? Which one did we fix again? And at that point, I don't know, I'm sure like most of you had better organizational skills than I did, but I had to go through this and I did not have a good time trying to figure out, okay, what is where and, what did we do with it? And that's kind of the purpose of product lifecycle management. It deals with, where are we in with making a product and that product's design, and what do we do with it? So I'm going to bump over to the next slide. Let's cover, what is PLM? What is product lifecycle management? It's a process. It's pretty like self-explanatory. It's a process of tracking and managing a certain product from development to production, and eventually like when it gets obsolete or when you need to get rid of it or you need to replace it, end of life process. And something you'll notice if you go once you start working as an engineer is you're going to be involved. Well, depending on where you are and what kind of field you work in, you will be involved in at least one of these phases. You might be involved in R&D, so essentially developing, initially designing the part and prototyping it, doing some of the initial testing. You might be involved in the production side where you might say, okay, the engineers over there said, all right, this part's ready to go. or this product is ready to go. This machine works now. So now we gotta test it, make sure that it lives up to everything we need it to do, and then we can like quote unquote initially release it. We can put it on the market. We can initially install it in, if like for an example, for an undergraduate student project, we can install it in where we need it to go. And then after that, I'll take, let me use actually like SolarLight from ESW, right? It's essentially a project that's been commissioned to put a self-contained like solar lighting system on UCSD's challenge course, right? So, the initial engineering process would be like designing such a system, prototyping would be like, making essentially proof of concepts for that, and then testing initial release would be actually installing it on the challenge course and saying, all right, we're good to go. Then you get to improvements, which is maybe somewhere down the line, challenge course says, hey, can we like get a machine like, or a little like, I guess, piece of equipment in there that allows us to turn this thing on and off remotely. Maybe we don't want it to run on a certain day, or we do want it to run on another day, or we want it to start on at a certain time. You could have a small squad of engineers come out and say, all right, we're going to design a system, an improvement to our existing system that allows this functionality. Also at the same time, or maybe something, it's been installed in there for a couple of years, and some kid falls off the challenge course and like catches the wire and like rips it out, Then you have, oh boy, it's not going to work like that. Then you have like your repairs and fixes. Essentially, like not only do you fix the wire that got pulled out by the falling kid, you also now you have to go back and actually like design that part again, so that maybe a falling kid won't rip it out of the challenge course. And that's kind of that's part of repairs and fixes. Not only do you remedy something that went whoops, you engineer that problem out of existence. And then you get to end of life, right? Which is where, oh, maybe we need something else, a new system. Maybe they finally run an electric wire out there, and now you want to connect it to the grid instead, because for various reasons, I don't know why, but maybe you do, right? And so your job would essentially be like decommission the system. Maybe if you had a part that was your company designed a part, let's say a switch that was installed on somebody's wall, you might have to like refer the people who are buying from you to like a different manufacturer, or you might have to create a successor for the part. There's a whole, I guess, a lot of different paths you can take with end of life, but the general principle remains the same. You're taking your part and you're saying, all right, we're done with it, no more. And many of these changes are documented using something called engineering change orders, or ECOs. I'll pull up an example of that in a little bit, but let's go ahead and move on to the next slide. Talk about what's an ECO. Lauren, I'll let you take this one away.
So, like Jeremy was saying, an ECO is essentially a standardized method of ordering the way that changes happened and when they happened, and what revisions did occur and why did they occur. So that can be for anything from parts, assemblies, drawings, really anything that you're changing, you want to try to be keeping track of. So ECOs can help if you send out a product and your user comes back and is saying, oh, this doesn't work, there's something broken. So you're fixing something for that, and you're needing to say, okay, someone said XYZ doesn't work, so we did this to fix that problem. It can also be for each stage of your prototyping and your design process for something new. Yeah, overall, just keeping track of what's happening, when is it happening, and why is it happening. ECOs will generally cover for multiple part revisions, like we have in this last point here. So the same part can be replaced over multiple products. So the ECO would be covering for all of those changes that are being made.
All right. And I'll go ahead and bring up an example of an ECO, right? Let's say I'm developing a machine, that sorts trash from recyclables, and I found out, okay, the servo I'm using, isn't powerful enough for certain pieces of heavy trash. So I'm going to go ahead and bring up a website right now. Let me see where it is. Give me just a moment. Sorry, I got to go and actually grab the website I want to go into. But let's say, I'm using a specific servo, right? And I find out, oh shoot, it's if a kid puts a watermelon in the trash can, the servo doesn't move it, it's stuck, right? Can't move maybe it can't move the watermelon, and that's a problem because people throw away watermelons. You know, people aren't just throwing away like pieces of paper, plates, and water bottles. They're throwing away heavier stuff, and your design isn't. You find out, okay, your design is not going to work because the kid got a watermelon stuck in it. So let's say, okay, then the easiest solution to that is, hey, maybe just get a more powerful servo. If we have the material to do it with, it doesn't really hurt. Doesn't really hurt to do so. And let's say I'm going to bring up this random piece as an example. Go to RC servos. Let me switch my screen. So what needs to be changed? A new servo, and we need new revised mounting points. So I'll go ahead and switch my screen over real quick, and screen 1. And can you guys see that? Essentially, let's say maybe I was using this servo over here, right? And realized that wasn't working, and then I look at the spec sheets, I do the math, and I say, okay, I need that guy instead, the big one, right? And obviously, you can see like this servo is bigger, it has a different footprint, the screw holes are different, spaced out differently. And all right, so I'm going to not only need to make a change, I'm not going to be able to just pull out the old servo and put the new one in, the point where I'm going to have to actually change some parts of my actual arm assembly that's the servo stuck onto. So I'm going to go and switch my screen back over. An ECO here is useful to keep track of, what parts did I change. So in this case would be like, I got a new servo motor, so I changed the assembly, what's it listed out in the assembly, bill of materials in there. It's no longer servo number 1, it's servo number 2. And I also changed, the mounting plate, and this covers also the most important part is why they were changed. Yes, we got a new servo. Why did we get a new servo? Because a kid got a watermelon stuck in a trash can. So essentially the idea behind this is, documenting fixes is incredibly important in the engineering process. I cannot, stress how important documenting why you did a thing is. They say engineering is made out of 2 parts. I'm kind of going off the script here. It's designing solutions for problems and being able to explain those solutions to whoever wants to ask and wants to know about it. And essentially being able to document every single change, every single solution you have, will save not only you, but maybe your teammates a lot of time in trying to figure out, why we did something, because it prevents you from making that same mistake later on. And companies will often use like some fancy like PLM software for this. They'll have, stuff, they'll have all their nice little part numbers listed out, and they'll have, all their nice little revisions stuck in there. But well, undergraduate student projects and maybe, even slightly more advanced, like student projects, don't really have the budget for that. Budget's better spent on buying parts and buying material than actually just like faffing around with software that don't really need to use unless you're a company with like 7 offices in like 4 different countries, and you have to keep track of everything like on a higher level. Something as we mentioned before, Google Drive works just fine for this kind of thing, keeping track of just a stack of documents. All right, we changed this, and why did we change it, and what did we do? I'm gonna bump over the next slide, and for an ECO for this might be, obviously this would be like on a maybe a Google Doc or something, but it's just something simple like this. An ECO for the change might look like name of the change, smart source is your product name, servo replacement. So it explains, in a nutshell, what are we doing here? In the description, why did we change it? Current servo number 1 has insufficient torque for moving certain loads. The watermelon stuck in the system. Replace it with servo number 2. Then we got to revise the mounting hardware to accommodate a servo, because if you recall back to the picture, servos are different sizes. So your changes here are, your sorted base assembly. So that's where everything goes into, your assembly of all the mounting plates and all the screws and all the servo and, the gears and whatnot. And your old revision was A. Your new revision is B. Obviously, move down the line, but this isn't always the case. You can make an ECO for a prototype change. Maybe you want to test it. And so you would designate, and we'll get into this a little later, but you might designate instead of B, you might designate A to A1 or something. So that way people know, and you can get into these kinds of conventions later on, people know hey, we haven't finalized the change yet. We're kind of just like, messing with it and seeing if it's going to work, right? You can document these kinds of like prototype changes. You can document these kinds of, okay, we're trying something new. Let's see if it works. And then the description of change is pretty clean. You want a clear, concise, and good explanation of, what did we do here? And description of change would be, replace servo 1 and the included mounting bracket with servo 2 plus the bracket. So, basically it's saying you took out your servo 1 out of your bill of materials when you were assembling this whole thing, and you put in servo 2 into your bill of materials. Pretty simple, pretty straightforward, right? Any questions? Is that clear, more or less? And then your second step is, mounting plate. So we had a mounting plate, because you can't just like glue the servo on there and say, all right, go, buddy. I mean, you can, but that's usually pretty bad engineering practice. And well, unfortunately, epoxy is only a solution when you want it to be permanent. And well, so a lot of engineering, you don't really want it to be permanent because stuff breaks, and then you got this giant blob of epoxy to deal with. So we made a mounting plate. It's basically a piece of aluminum. We drilled some holes in it with like threaded the holes. Then you just run a bunch of screws through the mounting points and servo into this piece of aluminum. Now, oh shoot, the new servo is like twice the size of the old servo, so these holes don't work anymore. So you're going to revise this mounting plate. You're going to change where the holes are and change the screw hole dimensions and positions to match the new servo. So essentially in this ECO, this is a very, very simple ECO. I actually sent out an ECO today that was like 30 different parts, but for the example here, we're just using 2 parts. Pretty simple. Item. You have 2 different pieces being revised in your ECO, and there's description. What is being changed, where was it previously, what is it now, and what did we change? And you can do this for every single item, and that way someone can pull up this document and say, all right, down the line when there's somebody else is trying to do research on a similar product, maybe in your project team, right, or in your student org, they're doing something that kind of has a similar little fit. They can actually go through your documents and say, all right, what kind of fixes does this project make on their journey to success, and what kind of issues did they run into, and how did they solve those issues? They can go back and look and say, they did this to solve their problem. So maybe we have a similar problem. We can go back and use their method, and maybe it'll work for that too. Saves a lot of time, saves a lot of trouble, and basically make sure is the things that you've learned and the solutions you've developed don't just get used once. They get used for basically perpetuity. So anybody have any questions on that? Any concerns? Maybe something that's not clear? Feel free to speak up at any point. Ping me in the chat. All right, I'm gonna go move on to the next slide. And Lauren, I'll let you get to this one as well.
Yeah, so kind of wrapping up a little bit. Oh, before we go there, we have a question.
Oh shoot, right. That's a very, very good point. And I'm sorry, I actually forgot to show a specific thing that I was going to show. So I'm gonna go ahead and bring up this. You store ECO in the BOM. You actually don't. Essentially, the BOM is usually stored under the assembly. So if you have a part, right, or you have a machine, and it has all these parts in it. So that's your bill of materials and all those parts that are in it. The ECOs are listed on a higher level than that, because essentially ECOs describe the change that you made to your part, and in your part is the BOM. You can't store information like that, but I will show you actually an example of a filter I used. I was doing essentially a little bit of like replacement on, I think. We're going to switch to screen 1, and I'll show you. Okay, this is a data sheet for a company, a certain line of filters for a company. Essentially, they're like high precision filters used for catching stuff. In this case, it was used in essentially the main coolant supply line for some fancy heat sink, right? That was the project I was working on. And, I needed to look through all the spec sheet, but you can see here, sure, this revision table isn't like complete because, otherwise there would be no space for it. But you can see in this revision table, revision L, revision M, revision N, revision O. It's been through like, over a dozen revisions by now. And every single revision is documented, and it specifies in this revision table, what ECO was the revision part of. You can see like ECO 1657. an updated 17.4 heat treat to from H900 to H1150. Essentially, that's specifying that, for 17.4 stainless steel, we changed how we heat treat it. And
can we zoom in on that a little bit so people get a
yeah,
better view?
let me go ahead and zoom in, right? Let's go and, yeah, go and look at this revision table. And this is like, this is a full company revision table. I pulled this data sheet off of their website, right? You can see, ECO 1557. So ECU, we don't know what ECO 1657 is, right? We don't know exactly, if you have a drawing, what that encompassed. But if you go back and look at the company's documentation, somebody can go back and say, okay, what was ECO 1657? And I don't know, like, maybe it was, oh, we changed how we handle 17.4 because previously, whatever the previous heat treating method was, prevented the 17.4 stainless steel was not reaching the specified strength conditions that was required of it, right? And so we changed how we heat treat it. And then you can reference back to ECO 1657 just based on this little note in the revision block and say, look through the list, look why the change was made. And it makes it much easier. So if you're issuing these files to maybe your team to work on, they can go back and say, okay, we had a fix, and why did we fix it? Does that make more sense? Is that clear?
Yep.
All right, great, perfect. I'll go ahead and zoom back out. So this is only one example. This is something I worked on first. Well, I didn't work on this data sheet, but I read this data sheet, personally, and I noticed the revision table. I would show you guys some stuff from my work, but I don't know if that's entirely legal, so I will refrain from doing that for now. But that's a good example of, in this case, what kind of stuff you will see, what the use of an ECO is, and how these big companies actually keep track of all the stuff that they work on and how they manage to not only leave a paper trail for themselves, but leave a paper trail for maybe the customers or whoever else is trying to, someone down the line, maybe a new employee later down the line, just trying to figure out, okay, what did we fix in here, and how do we prevent this from happening again? All right, so I've taken more than enough time. Go ahead, Lauren. I'm sorry.
Yeah, so we can switch back to the PowerPoint screen.
All right. Oh, my bad.
And then I can kind of wrap it up. So yeah, Jeremy kind of went over a lot about product lifecycle management and sort of the standardized approach to that. So I'll just cover a few other tips and tricks that I think we've already mentioned a bit, but I'll emphasize a few more things that mostly all revolve around standardizing a documentation process. So in any life cycle for any sort of product or project, you're going to have different points throughout the life cycle. So you're going to have your different prototyping stages. So it's where you're kind of just messing around with it and saying, maybe this would work or maybe that would work. I'm not really sure. But then you're going to get to a point where you're going to say, okay, this is, I think, what's going to work. So that's kind of a finalized product in a sense. And then that's going to be the one that you're maybe printing out, 3D printing, or you're getting it done at a machine shop, and then you're doing your testing with that. So you want to, it's helpful to identify the difference between your kind of messing around and testing more virtually with prototyping, or your actual, what are you going to be machining out and testing with as a product. So one potential way that you can distinguish between these versions is to use two different types of revision systems. So for right now, in all of our examples, we were using revisions that were letters, so A, B, C, D, and so on. So you can use something like that for your more production releases. So what are you actually going to print out? What are you going to machine and use? And then for your prototyping, you can use numbers. So you're still using revision A, but it's revision A1. And that's kind of saying, okay, I'm taking this initial design that we printed out, but I'm going to change a few things on it, but I'm not totally sure if that's going to work. So then you would have maybe, let's say, aluminum block, because that's what we're using. So you have aluminum block A, and then you have aluminum block A1, A2, and then maybe you have revision B. So it's sort of a way to keep track of where in the cycle you are and to know this is more finalized and these are a bit more messing around, seeing what the changes are. And then, but as a final emphasis, is really just document everything. Um, it's easier to take a bit of time at the beginning of a project to set up a proper documentation system than it is to be either yourself later and down the line, whether it's a month or 6 months, going back to where you started and trying to say, what did I do here? Why did I do that? Whether it's that or it's you worked on a project for a year and then you're no longer on that project and someone else is, and they're coming in and they're trying to figure out what on earth did you change? Why did you change it? You're not there to help explain it. So they need somewhere that they can reference. So, like we were saying, Google Drive is a fantastic place to use for that, but you want to just make sure that you're having a standardized format. So, your standardized naming convention for your files is a big part of it. So, that's the keeping track of the revisions, keeping track of who was designing parts, when they were designed, the ECOs, everything like that. And then you also, in a way, want to have almost a documentation for your documentation. I know that sounds incredibly redundant and kind of pointless, but you want to have at least one place that lists out everything of this is the standard way we're going to do it. So whether it's you want all your files to be saved the same way, where it's product name underscore revision underscore like your initials or something like that. You want to be having a place where you keep track of this is the standard way we do everything. Because if someone new joins your project and you and the rest of your teammates who have been on with it from the beginning and you created the naming convention, you're going to know what everything means. You're going to know what the abbreviations mean. You're going to know why you name something a certain way or why you save it in a certain file. But someone new isn't going to know exactly why you're doing that or what they should be doing. So you want to have one standard place that's almost like an index or an encyclopedia that they can look up and say, okay, I have this part file. Where do I save it and how do I save it? So it's just a way of keeping everything standardized across a project, regardless of who's coming or going and who's looking at it. That it really saves a lot of time. I know I've had a couple different jobs or internships that I've come in and it's just the files are a mess and no one knows who was the last person to do it. And so you want to be able to have a way of tracking who was using those files or where are those files so that you don't lose anything. It saves everyone a lot of time and a lot of headache. Um, yeah, I think that's kind of my spiel for documentation. Again, Google Sheets, Google Drive is fantastic for it. So just sit down with your team when you start and come up with the format, and I promise it will save you a lot of time in the long run. Um, yeah, do we have any more questions on anything that we've covered? No, doesn't look like it. Jeremy, you got anything you want to add? Any
Um,
last bits?
Not really. I do understand that this workshop is a little bit not only shorter than the previous workshops, but it also deals a lot more with like admin things rather than exactly how to use SolidWorks. But the idea behind this is SolidWorks. What I wanted to leave you with is SolidWorks is a tool, right? A lot of people see SolidWorks as it's kind of as engineering thing that does all the things. No, no, no. SolidWorks is a tool for your engineering process. It makes certain things easier. Obviously, you don't have to draft by hand. You can run simulations. Speaking of simulations, winter quarter, stay posted. We actually have a couple grad students lined up to teach a whole series of simulations. So that'll be super dope. But SolidWorks makes things easier. But SolidWorks in itself is just a tool for engineering. So SolidWorks, learning how to do, go through the proper engineering process, learning how to document everything you're doing, that's a big part of SolidWorks as well. Essentially making sure that whatever you do in SolidWorks is documented well, and using the features in SolidWorks, such as like custom properties, drawings, things like that, just to be able to keep track of, proper engineering processes. So, keep that in mind. Always remember, SolidWorks is a tool, and also design, and if you think about referring back to workshop number 1, we covered, making a part by using design intent. A large part of design intent, as I mentioned before, is being able to express why we're doing something. Not only what is this part, but what did we want from this part, and being able to reference your ECOs, reference your revisions, reference what changes did we make and why did we make them, is a huge part of being able to express what do we want this part for. So I mean, I don't really have much else to say. I'll go ahead and leave us on that note. But yeah, remember, document everything and make sure that whenever you work on a part or a product or an assembly or anything in between, make sure that any tips in preparing. Oh, sorry, I'll get to your question in a little bit, but essentially, whatever you're working on, make sure that not only does it make sense to you what you did, but make sure it makes sense to someone else down the line what you did. We're getting a question here that says, any tips in preparing a PM position interview? Sorry for early broad question. PM, I'm guessing that refers to product management or
project manager usually.
Project manager.
Yeah, so for EWH, when we interview for our project manager position, we're generally looking for someone who honestly is very organized. This workshop, outside of SolidWorks, a lot of these kind of knowledge ideas and techniques are applicable to things outside of SolidWorks. So a lot of these skills are things that we do look for our project managers. Yeah, organization, really good communication. I guess if you're being a project manager, you have to interact with a lot of people. You have to interact with teams, team leads, executives for your student org. So I think just being really good at communicating and listening as well. It's also really important.
Very well said. I think one of the things, as someone who's led an undergrad project for a couple of years before, I guess, quote unquote, moving up the chain, something I learned, and I actually had to get used to myself, and this isn't really dealing with the interview, but actually for the position itself. And if you bring it up, maybe that it could be a very good point, because I learned this, the hard way. And being a leader or a manager for a project is less about you being able to do everything better than everyone else, and more about being able to essentially organize everyone who can do things better than you in such a way that they get it done. I had to a few times had to force myself to step back, from sticking my hands in everything and trying to do all this work, to kind of step back, work on funding, work on, support, essentially supporting my teammates who had, if I'm being completely honest, way more technical skill in certain areas than I will ever have in my life. And, my job essentially was to support them, to give them the resources and give them the guidance they needed to accomplish, that project, accomplish that goal, accomplish whatever we were working on. So I don't know if that's really applicable per se to an interview, but I know it is very, very applicable to, actually, if you land the position where you're working on, take a step back, focus more on supporting your people than actually just trying to do everything yourself.
I absolutely agree with that. Yeah, hopefully that's a little helpful. Any other
No problem.
questions? I'm gonna go ahead and stop the recording here.
All right, sounds good.